అండ్ దాని సోర్సెస్ కూడా ఇంపార్టెంట్.
microspore
సో అందులో
This
చూస్తే
process is
ఫస్ట్
termed
క్వశ్చన్,
as microsporogenesis.
in the constitution of
Here,
India
the
the term federal
microspore
appears
tetrads
in.
are haploid in
సో
condition
భారత
and the
రాజ్యాంగంలో
pollen mother cell
ఏదైతే
are
టర్మ్
diploid in
ఉందో
condition.
ఫెడరల్ అనేది, సో
The
appears in
microspores found
preamble
are
part 3
arranged
of
in
the
a
constitution
cluster of foci
article
and
368
together called
DMO
microspore
none of the
tetrad. These
above ఇచ్చారు.
microspore tetrads
సో డైరెక్ట్ గా
are
ఏంటంటే మనకి ఈ టైప్
different
ఆఫ్ క్వశ్చన్
types.
కూడా అడుగుతుంటారు.
Tetrahedral
సో
type,
ఫెడరల్ దీని
isobilateral,
మెన్షన్
linear,
చేయడం జరిగిందా లేదా
T-shaped
అనేది.
and decussate. Out of these, the
సో ఇండియన్
tetrahedral
కాన్స్టిట్యూషన్ లో
type is most
మెన్షన్
common
చేశారా లేదా అని
tetrad,
కూడా
which
అడిగే
is
అవకాశం
present
మనకు
in the
ఉన్నది.
cells
సో
of beta petal.
ఫస్ట్ నేను ఫెడరల్
So
గురించి
friends,
చెప్తాను.
as
ఇది
the
వన్ ఆఫ్
anther
ద
get
ఇంపార్టెంట్
mature
టాపిక్
and
కాబట్టి.
dehydrated, the
సో ఏదైతే ఈ
microspores
ఫెడరల్ టర్మ్ ఉందో
dissociate from each other and
appears
develop into
in
pollen
part
grain.
1,
So let's see what actually
part
the pollen grain
first.
is.
సో ఆర్ part 1
Pollen
of
grain.
the constitution.
The study of
సో ఇది
pollen
మీకు
grain
గుర్తుండాలి.
is called
సో ఇది ఏం
palynology.
చెప్తుందంటే ఏదైతే
The study of
ఈ
pollen
ఫెడరల్ అయితే
grain
ఉందో,
is
సో ఇన్ ద
called
కాన్స్టిట్యూషన్ ఆఫ్ ఇండియా ద టర్మ్
palynology.
ఫెడరల్ అయితే
It
ఉందో,
represents male
ఇది ఏమని చెప్తుందంటే
gametophyte.
ఈ స్టేట్
The
అబౌట్
formation
ది
of
పీపుల్
pollen grain from microspores
The
is
people
termed
of
as
India.
microgametogenesis.
సో ఇట్ స్టేట్స్ అబౌట్ పీపుల్ ఆఫ్
microspore
ఇండియా
is also haploid and pollen grain is also haploid.
హ్యావింగ్
This process is termed
పీపుల్
as
ఆఫ్ ఇండియా హ్యావింగ్. ఇది మీకు
microgametogenesis.
చాలా వరకు ఏంటంటే డైరెక్ట్ గా
Have you
కూడా
seen hibiscus?
మనకు ఈ టైప్ ఆఫ్ క్వశ్చన్
Absolutely.
అడుగుతుంటారు
If you
ఎగ్జామినేషన్ లో.
touch
సో ద పీపుల్ ఆఫ్
open
ఇండియా
anthers
హ్యావింగ్
of
సోలెమన్లీ
the
ఇంటూ
hibiscus,
సావరెంటీ,
you'll found allows the deposition
solemnly
of
into
alloys
sovereignty,
pollen powdery
democracy,
that actually the
justice,
pollen grain. That actually
liberty,
the pollen grain. The pollen
equality.
grain has two
So,
prominent
ఇవన్నీ
wall layers. The
ఏదైతే
exant
ఈ
and
పార్ట్స్ 1
intern.
ఉందో అందులో మెన్షన్ చేయడం
The exant
జరిగింది.
is
అదే విధంగా
outer
పార్ట్
hot
3
layer. It
పార్ట్
is
3 ఆఫ్ ద
irregular
కాన్స్టిట్యూషన్
and
ఏదైతే ఉందో
discontinuous
ఇది
layer,
దేని గురించి డీల్
which is
చేస్తుందంటే
made up of
ఫండమెంటల్ రైట్,
sporopollenin.
ఫండమెంటల్
The
రైట్స్. ఇది
sporopollenin
మీకు గుర్తుండాలి.
is
సో
one of
ఆర్టికల్
the
ఫండమెంటల్
most
రైట్ లో
material
ఆర్టికల్
resistant organic
12 నుంచి
material in
35
the
వరకు.
world. And no enzymes
ఆర్టికల్
that
368
degrades
ఏదైతే
the
ఉందో
sporopollenin.
ఇది దేని గురించి అంటే
The exant pollen
మనకు
grain
ఇదే
has
విధంగా కూడా
a
అడుగుతుంటారు. సో ఆర్టికల్
prominent
368 ఏంటంటే
aperture is
ప్రొవిజన్ ఆఫ్
called
అమెండ్మెంట్ ఇన్
jump pore,
కాన్స్టిట్యూషన్.
and
So,
where it is
provision
present
of-
where the sporopollenin is absent.
ప్రొవిజన్ ఆఫ్
The
అమెండ్మెంట్
jump pore is
Constitution.
surrounded by
So,
a
preamble
hole
అనేది
on
part-
the microspore. It means a
పార్ట్
pollen
ఫస్ట్ ఆఫ్
grain.
ద
It emerges
Constitution
during
సంబంధించింది.
germination
So,
as a pollen tube.
ఏదైతే
The
టర్మ్
inner
ఫెడరల్ ఉందో
layer
సో
is
దీన్ని
called intern.
కాన్స్టిట్యూషన్ లో
The
మెన్షన్
intern
చేయలేదు.
is thin
సో ఆప్షన్
and
డి అనేది
continuous
కరెక్ట్.
layer.
సో నన్ ఆఫ్ ద అబోవ్.
And it is
సో మనం ఇందాక చెప్పింది
made up
ఇదంతా
of
దేని గురించి అంటే
pectin
ప్రియాంబుల్
or
గురించి.
cellulose or
సో
pectin
ప్రియాంబుల్ స్టేట్స్ ఏమని
cellulose.
చెప్తుందంటే
The
ద పీపుల్ ఆఫ్
cytoplasm
ఇండియా,
of the pollen grain
ఇట్ స్టేట్స్
is
అబౌట్
surrounded
పీపుల్ ఆఫ్
by
ఇండియా.
plasma
అది కూడా
membrane.
సావరెంటీ,
At
డెమోక్రసీ,
maturity,
జస్టిస్, లిబర్టీ,
the
ఈక్వాలిటీ రిలేటెడ్ టు
microspore
ప్రియాంబుల్.
nucleus
పార్ట్ 3 ఆఫ్ ద
undergo
కాన్స్టిట్యూషన్ ఫండమెంటల్ రైట్స్
karyokinesis
సంబంధించింది
and
అండ్ ఆర్టికల్
produces
12
two
అండ్
nuclei,
ఆర్టికల్ 35
and
సంబంధించింది.
the separation
అదే
of
విధంగా ఆర్టికల్
cytoplasm.
368 ఏంటంటే
It means
ప్రొవిజన్ ఆఫ్ అమెండ్మెంట్
cytokinesis is
ఆఫ్
not
కాన్స్టిట్యూషన్.
equal.
సో
That
మీకు
it has
అట్లీస్ట్
one larger
ఏదైతే
cell and one
క్వశ్చన్ లో
smaller
అంటే
cell.
మనకు అల్టిమేట్ ఏంటంటే క్వశ్చన్ ఏం అడుగుతున్నారు అండ్ ఆప్షన్ ఏమి ఇచ్చారు, ఈ రెండు ఇంపార్టెంట్. సో ఒకవేళ కనుక మనకు క్వశ్చన్ ఏదైతే ఇస్తారో దానికి సంబంధించి మనకు తెలియకపోయినా కూడా ఏమి ఇచ్చారు అనేది చూసినా కూడా ప్రియాంబుల్ అనేది పార్ట్ 1 ఆఫ్ ద కాన్స్టిట్యూషన్ సంబంధించింది అండ్ పార్ట్ 3 ఏమో ఫండమెంటల్ రైట్ అనేది, ఆర్టికల్ 360 ఏమో ప్రొవిజన్ ఆఫ్ అమెండ్మెంట్ కాన్స్టిట్యూషన్ సంబంధించింది. సో ఈ మూడు కరెక్ట్ కాదు కాబట్టి ఫెడరల్ అపియర్స్ దేంట్లో అంటే నన్ ఆఫ్ ద అబోవ్. సో ఆప్షన్ డి అనేది కరెక్ట్ ఆన్సర్. నెక్స్ట్ క్వశ్చన్, ఇండియన్ ఫెడరల్ స్ట్రక్చర్ ఈజ్ ఇన్స్పైర్డ్ బై విచ్ మోడల్ ఆఫ్ ద కంట్రీస్ గివెన్ బిలో. ఏదైతే ఇండియన్ ఫెడరల్ స్ట్రక్చర్ ఉందో సో ఏ కంట్రీ నుంచి ఇన్స్పైర్డ్ అవ్వడం జరిగింది? యుఎస్ఏ, కెనడా, స్విట్జర్లాండ్, రష్యా. సో ఫెడరల్ స్ట్రక్చర్ ఆఫ్ గవర్నమెంట్ ఇన్ ఇండియన్ కాన్స్టిట్యూషన్ ఈజ్ టేకెన్ ఫ్రమ్ కెనడియన్ కాన్స్టిట్యూషన్. సో ఇది మీకు గుర్తుండాలి. చార్టర్ ఆఫ్ ఫండమెంటల్ రైట్స్ అండ్ పవర్ ఆఫ్ జ్యుడిషియల్ రివ్యూ అండ్ ఇండిపెండెన్స్ ఆఫ్ జ్యుడిషరీ, బ్రిటన్ కాన్స్టిట్యూషన్ అండ్ ప్రియాంబుల్. సో ఇవన్నీ ఎక్కడి నుంచి తీసుకోవడం జరిగిందంటే యుఎస్ఏ. ఇండియన్ ఫెడరల్ స్ట్రక్చర్ అనేది ఇన్స్పైర్డ్ ఫ్రమ్ విచ్ కంట్రీ అంటే కెనడా. సో బి అనేది రైట్ ఆన్సర్. అదేవిధంగా రష్యా సంబంధించి చూస్తే ఫండమెంటల్ డ్యూటీస్ ఒకటి అండ్ 5 years ప్లాను. సో పంచవర్ష ప్రణాళిక ఉంది కాండి. సో అది కూడా రష్యా నుంచి తీసుకోవడం జరిగింది. సో కాన్స్టిట్యూషన్ ఒకటి అండ్ ప్రియాంబుల్, ఈ 4 ఏదైతే ఉందో ఎక్కడి నుంచి ఏ కంట్రీ నుంచి బారో చేయడం జరిగిందంటే
Honey, maybe we should just call it a night.
You go ahead. I gotta finish these centerpieces and rearrange the seating chart. Yes.
Hello.
Mom, now is not.
Let us generalize our topic once again with mind mapping for our better understanding, right? Flower. Flower is a site of sexual reproduction. It is composed of 4 whorls: calyx, corolla, androecium and gynoecium. Out of these whorls, androecium is male reproductive organ which is composed of stamens. The stamen contains 2 main parts, the filamen and anther. The anther is fertile portion of the stamen. It contains 2 lobes and each lobe contains 2 sacs or 2 thecas, and each theca contains a microsporangium. The microsporangium appears circular in its outline and composed of 4 wall layers: epidermis, endothecium, middle layer and tapetum. The outer 3 wall layers perform the function of protection and going to help in the dehiscence of pollen sacs. The tapetum is nutritive layer going to provide nutrition to the developing pollen grain. Inside the tapetum, the cells of the sporogenous tissue undergo reduction division and form 4 haploid microspore tetrad. And these haploid microspore tetrad undergo equational division and develop into pollen grain. The pollen grain represents male gametophyte. It contains 2 cells, vegetative cell and generative cell. The pollen grain is also used as advantageous as it is nutritive and also disadvantageous as it causes severe allergies for human life. But it is possible to store in liquid nitrogen at -196 degrees centigrades. So friends, now the Pinky and Dinky both understood clearly that why their plant is having a change with growth of leaves, flowers and fruits. That each flower gives out a fruit, through sexual reproduction. Yes, now we'll again meet in the next session that they both went to their home happily. And for us also, it's time to off the session. Now, I am very thankful to our Telangana government and our respected Secretary, Sir Ronald Ross Garu, and my special thanks to my principal, Sir M. Devadas Garu, and we'll again meet in the next session with another interesting topic, structure of gynoecium, and don't miss it. Thank you one and all. Jai Bhim.
గ్రూప్ 1, గ్రూప్ 2, గ్రూప్ 3, గ్రూప్ 4 ఉద్యోగం ఏదైనా చూడాల్సింది టీశాట్, వినాల్సింది టీశాట్ పాఠ్యాంశాలే, అనుసరించాల్సింది టీశాట్ నెట్వర్క్ నే, పాల్గొనాల్సింది టీశాట్ క్విజ్ లో మాత్రమే. లక్షలాది మంది నిరుద్యోగులను వీడియో క్లాసుల ద్వారా గ్రూప్ 1 ఉద్యోగాలకు సిద్ధం చేసిన టీశాట్ తెలంగాణ ప్రభుత్వం ఇటీవల విడుదల చేసిన గ్రూప్ 2, గ్రూప్ 3 ఉద్యోగాలకు క్విజ్ కార్యక్రమం నిర్వహిస్తోంది. టీఎస్పీఎస్సీ ఆధ్వర్యంలో భర్తీ చేసే ఏ పోటీ పరీక్షకైనా నిరుద్యోగ యువతకు టీశాట్ నెట్వర్క్ అందుబాటులో ఉంటూ పరీక్షకు కావలసిన అన్ని వనరులను సమకూర్చుతోంది. వినియోగించుకోండి, విజయాలను మీ సొంతం చేసుకోండి.
TSPSC Group 4 first episode. ఫస్ట్ క్వశ్చన్. కలకత్తా, బొంబాయి మరియు మద్రాసులలో 1865లో హైకోర్టులను స్థాపించింది ఎవరి కాలంలో? ఆప్షన్ ఏ లార్డ్ లారెన్స్, ఆప్షన్ బి లార్డ్ క్యానింగ్, ఆప్షన్ సి లార్డ్ మాయో, ఆప్షన్ డి లార్డ్ రిప్పన్. Your time starts now. The correct answer is option A, Lord Lawrence. Next question. భారత జాతీయ కాంగ్రెస్ మొదటి మహాసభ ఎక్కడ జరిగింది? ఆప్షన్ ఏ బొంబాయి, ఆప్షన్ బి సూరత్, ఆప్షన్ సి కలకత్తా, ఆప్షన్ డి జైపూర్. Your time starts now. The correct answer is option A, Bombay. Next question. భారత జాతీయ కాంగ్రెస్ రెండుగా ఏ సంవత్సరంలో చీలింది? ఆప్షన్ ఏ 1907, ఆప్షన్ బి 1908, ఆప్షన్ సి 1909, ఆప్షన్ డి 1910. Your time starts now. The correct answer is option A, 1907. Next question. పుష్యమిత్రుడు స్థాపించిన రాజవంశం? ఆప్షన్ ఏ కన్వా, ఆప్షన్ బి శుంగ, ఆప్షన్ సి చోళ, ఆప్షన్ డి చేరా. Your time starts now. The correct answer is option B, Shunga.
भूत रहे बैठे भूत अंदर जानो मना है। चलो इधर से, चलो चलो चलो।
लुक छुप ना जाओ जी, मुझे दरस दिखाओ जी, आज क्यों तरसाते हो, जरा शक्ल दिखाओ जी.
Next question. పల్లవుల రాజధాని? ఆప్షన్ ఏ తంజావూరు, ఆప్షన్ బి కంచి, ఆప్షన్ సి సేలం, ఆప్షన్ డి మదురై. Your time starts now. The correct answer is option B, Kanchi. Next question. ఢిల్లీ సుల్తానుల రాజవంశాలు ఎన్ని? ఆప్షన్ ఏ 4, ఆప్షన్ బి 5, ఆప్షన్ సి 6, ఆప్షన్ డి 7. Your time starts now. The correct answer is
Hello friends, this is Deekshita Shri. I am studying 10th class in Bhadrachalam Girls. So before going to start a class, let me show you something. What do you observe in this picture? Yes, a group of people are gathered here. Actually, the group of students are gathered here for assembly. In our school, we also do that. After completion of assembly, all the students are dispersed into their classes, which means they are splitting up. Can you guess our topic name? What we are going to discuss? Yes, dispersion of light and a natural rainbow formation. So before going to take a class, let me ask you a question. What are in my both hands? Yes, this is a glass slab and this is a cardboard. What happened when the light incident on both these different material objects? Light behaves in different ways on both the surfaces. Let's see. So, when a light incident on this surface, what will you observe? It passes through this, which means it allows the light. And when light incident on another surface, what will you observe? It cannot pass through this, which means it does not allow the light. So, on the basis of this, the amount of light passing through a material, those are classified into three groups. They are transparent materials, translucent materials, and opaque materials. The first one is transparent materials. Materials which allow the light to pass through them are called transparent materials. One can easily see the objects on other side of a transparent materials. Some of the examples are water, glass, air, etc. And the second one is translucent materials. Materials which cannot allow the light to pass through them completely but only partially. Some of the examples are frosted glass, oiled paper, food oil, etc. And the third one is opaque materials. Materials which cannot allow the light to pass through them at all. Some of the examples are wood, iron, aluminium, wall, etc. Now, what do you observe in this picture? Yes, a prism. A prism is a transparent medium which separates the surrounding mediums and having a two plane surfaces which are inclined at a certain angle in such a way that the light incident on one of the plane surface and emergent from another plane surface. To understand the behavior of light when it is incident on a plane of a prism and passes through this, consider a triangular glass prism which having a two magnetic wave was produced when an electric charge was vibrates. And the vibrating of electric charge can create a change in the electric field. And a change in the electric field can create a change in the magnetic field. So this process continues with both the created fields or being perpendicular to each other and at a right angle to the direction of the propagation of the wave. The speed of the light in vacuum is constant for all colors. The speed of the light in vacuum is constant for all colors, but the speed of the light in media is depends on its wavelength. So, the electromagnetic wave traveling through a vacuum is same behaves like a ocean wave traveling through a water. Same like ocean wave, the electromagnetic wave was characterized by wavelength and frequency. The wavelength of the frequency is inversely proportional to the frequency, or the speed of the wave is equal to the wavelength and frequency. It is the universal relationship and applies to all the waves. As the frequency increases, the wavelength becomes smaller. So we know that the refractive index is the ratio of speed of the light in vacuum and speed of the light in media. So from this equation, we can say that the refractive index is depends on the speed of the light. We know that the speed depends on wavelength of the light. Consequently, the refractive index of the media depends on the wavelength of the light. So, from this we can say that both speed and refractive index are depends on the wavelength of the light. But here we notice that the light has chosen a different path. According to the Fermat's principle, the light ray selects its path which takes least time to travel. What is Fermat's principle? The light ray selects its path which takes least time to travel. So here, let me show you one thing. So here, see. So from this activity, we can see a clear path of the light. So a light ray always choose a straight line to travel. So when a light ray traveling through a prism, it splits into 7 colors and each color selects its least time path, and we have refraction of different colors to the different extenses. This is the result of separation of colors and producing a new spectrum of visible light. We know that the frequency is inversely proportional to the wavelength, or as the frequency increases, the wavelength becomes smaller. If we compare the wavelength in 7 colors in VIBGR, the red color has the longest wavelength and the violet color has the shortest wavelength. Because the refractive index of the red is low, hence it suffers low deviation. The refractive index of the violet is high, hence it suffers more. So by this we can say that the red light travels faster than a violet light in a glass prism. So we can say that when a white light passing through a prism, it splits into 7 colors. Then if we send a single color through a prism, does it split into more colors? Let's find out. So frequency. The frequency of the light is property of the source and it is equal to the number of the waves leaving the source per second. This we know already. So it is cannot change in any media. Hence frequency does not change due to refraction. So when a colored light passing through any transparent medium, it retains its color. Let's see. When a colored light passing through a prism, passing through any transparent medium, it retains its color. So, can you give an example in nature where we observe colors as we seen in the prism? Yes, we will observe colors on CDs. Here we can observe a multiple colors on CDs, right? So we will observe colors on CDs, soap bubbles, oil floating on the water or petrol flowing on the water, plastic scale, rainbow, etc. So we are going to discuss about a natural rainbow formation. So the rainbow is the best example of dispersion of sunlight by the many water droplets present in the atmosphere. This is the phenomenon due to combined effect of dispersion, refraction and reflection of the sunlight by the spherical water droplets of rain. Now, we already know about what is dispersion. What is dispersion? The white light splitting into 7 colors is called dispersion process. So now let's see what is reflection. Reflection is nothing but rebouncing back of light into same media is called reflection. So for example, this is your ball. When I hit your ball on the ground, what will you observe? Yes, it is again rebounces. In the same way, when a light ray falls on opaque material, it again reflects back into the same media. So, here we will observe that the angle between the incident ray and the normal is called angle of incidence, and the angle between the reflected ray and the normal is called angle of reflection. So, this is all about the reflection process. What is reflection? The process of the light ray again reflects back into the same media. So, this is called reflection process. Now, let's see what is refraction. Refraction is nothing but it is the phenomenon of changing the direction of the light at interface which divides two medias. For example, if we have your two medias, media 1 and media 2, when a light ray traveling from one media to another media, it changes its direction at the interface. So, this is called the refraction process. In this process, we will observe that the angle between the incident ray and the normal is called angle of incidence, and the angle between the normal and refracted ray is called angle of refraction. So, this is called a refraction process. When a light ray traveling from rarer medium to denser medium, after the refraction, the refracted ray move towards to the normal. So, here we can observe that the angle of incident is greater than the angle of refraction. So, let's see another example. When a light ray traveling from denser medium to rarer medium, after the refraction, the refracted ray move away from the normal. So, here we can observe that the angle of incident is less than the angle of refraction. So, when a light ray traveling from denser medium to rarer medium, after the refraction, if the refracted ray coincident with the interface, then it is said to be a critical angle. What is a critical angle? After the refraction, if the refracted ray interface with coincidence, then it is called a critical angle. Now, if the angle of incident is greater than the critical angle, then the light ray cannot go into the other media. It again reflects back into the same media. So, this phenomenon is called total internal reflection. Now, let's come back to the topic. The rays from the sunlight enters the drop near its top surface. At this first refraction, the white light is dispersed into spectrum of colors. Here, the violet deviated most and the red was least. Reaching the opposite side of the drop, each color is again reflected back into the drop. So, we know that because of total internal reflection. Arriving at the surface of the drop, each color is again refracted back into the air. So, at this second refraction, we will observe that the angle between the red and violet ore further increases when it is compared to those at first refraction. So, the incoming rays and the outgoing rays can be anything between the 0 degrees to 42 degrees. How many degrees? 0 to 42 degrees. So, although each drop disperses a full spectrum of colors, an observer is in a position can see only a single color from any one drop depending upon its position. For example, If a violet light from a drop reaches the eye of an observer, then the red light from the same drop doesn't reaches the eye of an observer. It goes elsewhere, possibly downwards or upwards of the observer eye. So, to see red light, he must see the drop higher than in the sky. So, the red light emerges at an angle of 40 degrees. The red light emerges at an angle of 42 degrees and the white light emerges at an angle of 40 degrees. So, if we observe between these two values, I mean 40 degrees to 42 degrees, we will observe remaining colors of the rainbow. So, then a rainbow is formed. Generally, how many colors present in a rainbow? Yes, there are 7 colors present in a rainbow. We all know that. Generally, in a rainbow, top portion contains red color and the down portion contains violet color. This is called a primary rainbow. Have you ever seen reverse order of these colors? I mean, top portion contains violet color and the down portion contains red color. If that will happen, what we call it? Let's see. The first one is primary rainbow. What is the shape of your rainbow? Yes, it appears in a bow in shape. But the rainbow we see is actually not a two-dimensional arc as it appears to us. The rainbow we see is actually a full circles. But many people oversee only a arc or in semicircle of a rainbow because they are standing on the ground and other half cut off by the horizon. Then he can able to see an arc or in semicircle of a rainbow. If you observe a rainbow from an aeroplane, you will observe a full circle of a rainbow. So, to order to see the rainbow from the ground, in the sky, the sun should be at the backward of the observer and the rain should be at the in front of the observer. Then he can able to see a bright colorful rainbow. So, this is all about today's class, dispersion of light and a natural rainbow formation. I hope you understood, guys. So, from this class, we learned that according to the Fermat's principle, the light ray selects its path which takes least time to travel. So, a light ray always chooses a straight line to travel. We already know that. So, the reflection process is nothing but rebouncing back of light into same media. This is called reflection process. Now, let's see what is refraction. Refraction is nothing but it is the phenomenon of changing the direction of light at interface which divides two medias. So, this is called refraction process. What is total internal reflection? If the angle of incident is greater than the critical angle, then the light ray cannot pass into the another media. It again reflects back into the same media. So, this is called total internal reflection. The light ray, when it passes through a prism, it splits into 7 colors. So, the process of white light splitting into 7 colors is called dispersion. The rainbow is the best example of dispersion of sunlight by the many water droplets of the rainbow. So, thank you for giving this a wonderful opportunity to me. I am heartily saying my thanks to my mentor ma'am, V. Sunita madam, and principal sir, M. Devadas sir, and secretary sir, Ronald Rose sir. So, thank you for giving this a wonderful opportunity to me.